Alright guys, welcome to the first math video. Give this a shot. Bear with me as I'm kind of getting used to this too. Keep in mind that at any time if you're confused, you can always pause the video and catch up with it, or pause it and raise your hand and I'll come over and help you the best I can. So today's lesson, we're going to begin to learn another method of solving linear systems. So we already learned how to solve with graphs, and we learned how to solve with the calculators, and then the most recent one we learned how to solve with the substitution method. This method is called the elimination method. So we have these key concepts for your notebook. These are the 3 steps that we're going to follow when we're solving a linear system using the elimination method. The objective is the same, so we're still looking for the coordinate pair or the ordered pair, the point, which will be a solution for all of the equations in the system. So if you still need time to copy this down, remember to pause your video and you will be able to do that. Alright, so we've got this example 1, and if we take a look back here at our first step, it's to add or subtract the equations to eliminate one variable. So if I'm looking at the variables here, I can add or subtract these things to cancel out and leave one of the variables remaining. So at this point we see that we have a 2x and a negative 2x. And just like when we're solving equations and we want them to cancel out, we know that these things are opposites. So if I take this first equation, this 2x plus 3y equals 11, and of course I still have down here my negative 2x plus 5y equals 13 for equation 2. If I add these things, I can add it kind of in a row. Well, let's draw that a little bit better. There we go. We can add this down the line. So we'll add these x terms, we'll add these y terms, and then finally we will add the constant terms at the end here. So let's start out with our x terms here. It's these guys right here. And so we're going to handle this as its own little problem here. So if I'm adding, remember adding here, 2x plus a negative 2x, we know that these things cancel out to 0. So we don't have to write them at all, in fact. When we move over to the next piece here, we're going to be looking at our y variables. And so here we've got our y variables. We've got 3y and 5y. Notice these plus signs. That's going to make sure that they are positive. If they're minus signs, they're negative, just like this negative 2x over here. So if I'm adding these terms, I have 3y plus 5y. And hopefully you know that we're just adding the coefficients, the numbers in the front, and that's going to give us a total of 8y. Alright, so 8y, of course, we're going to bring down our equal sign. And then we're going to take a look at our constant terms over here. Switch to our highlighter tool. And so we've got 11 and 13. Again, it's really important that we keep track of these signs, and in this case, because there's no negative sign, we know that they're both positive. So if I'm adding 11 plus 13, I'm going to get a total of 24. Okay? So at this point, we have the expression 8y equals 24. That will take care of step 1, which was to add the equations to eliminate one of the variables. Alright? And so I see step 2 is solve the resulting equation for the other variable. So if I'm looking at this, I see that I have 8y equals 24. At this point, we're only working with one variable, this y term. And if we're solving, that means we're trying to get it by itself. So I see that this 8y is 8 times y, and so to undo that, I'm going to do the inverse of multiplication, which you know as division. So we're going to divide by 8, and with all equations, we know that if we do something on one side, we need to perform that same operation with the same number on the other. So I'm going to divide both sides by 8. Alright, so we know that 8 divided by 8 gives us 1. So these cancel out. And all I have left is y equals, and 24 divided by 8 is going to give us 3. Alright, so we've now got the y part of this. We need to find the x part. And so just like we were doing with the substitution method, at this point, we're going to take step 3, which is to substitute in either original equation to find the variable of the eliminated variable. So if we take a look back at this example here, you can use either one of these examples. I'm probably going to go with this first equation because there are no negative coefficients. Notice in equation 2, we have this negative 2 in front of the x. So I'm going to use the equation 1, that first one there. So if I have this 2x plus 3y equals 11, and I know what y equals, I can simply substitute it in. Okay, so if I do that, I now have, hopefully you know this, 2x plus 3 times the quantity of 3. Remember, things inside parentheses we can call quantity. You can also just say parentheses. Alright, so we've got 2x plus 3 times 3 equals 11. At this point, we're going to go ahead and finish simplifying. So we know that 2x, there's nothing changing with that. It's just 2x plus. We know that 3 times 3 is 9. We still have equals 11 on the other side. At this point, we have a two-step equation, which you guys are pretty good at solving at this point. We see that we have to get this x by itself, so we have to get rid of the 9 and the 2. We have to get rid of the 9 first because we're using that opposite order of operations. So I have 2x plus 9 minus 9. And again, whatever I do on one side, I've got to do to the other. So 11 minus 9. And here we see the 9s are going to cancel. What I have left is 2x. Over on this side, I have 11 minus 9, which if I complete that, 2. At this point, I've got 2x equal 2, and I'm sure you can do the mental math and figure it out, but we want to show our work in preparation for keystones. So if I have a 2 times x, that means to get rid of it, I'm going to divide. Same thing on both sides, the number in front of the x, the coefficient. And so this 2 divided by 2 cancels to a 1. X equals 2 over 2, and therefore we know x equals 2 divided by 2 is 1. Alright, so now I've got my x term, I've got my y term, and so I'm going to put it in an ordered pair for my final solution. So my x term is 1, my y term is 3, and that's my ordered pair solution for the linear system. 1, 3. Alright, so remember, if you still need a minute to copy all of that down, you can pause it. If you need to watch again, just rewind the video. On to example 2. So just like we did with example 1, we added the variables to cancel them out. In this case, we see that these terms are the same coefficient with the same sign. So if we were to add them, it wouldn't work. That would give us 9x and 6y, and only these constants would cancel out. So it's not going to work out for us. So this time we're going to use subtraction. Very similar. So we're going to write our equation 1, 4x plus 3y equals 2. And we have 5x plus 3y equals negative 2. Alright, so the difference here is we're going to now subtract. Okay, and so that means if we're subtracting this equation, the equation 2 from the first one, if I put a minus out here, that's minus all of this. Okay, and so what that means is this negative sign applies to each term, the 5x, the 3y, and the negative 2. And what that's going to do is change all the signs. So if I'm going to move that over here now, still have my 4x, got my plus 3y equals 2. But if I'm subtracting the second equation, that's going to change to minus 5x minus 3y. And where this was a negative 2, now because we're taking the negative of a negative, that makes it positive. So now we can just go ahead and combine these like terms. So in this case, we see we've got our 4x and negative 5x. And if I combine those, I'm going to have negative 1x, or negative x. If I combine plus 3y and negative 3y, they cancel out. And then finally, if I combine these n numbers, they're both positive, so they're going to end up as 4. And so if I have negative x equals 4, obviously I trust you to be able to do the mental math in your head, but I'm going to show you the work anyway. I'm going to divide it by negative 1. And so I figure out that these negatives cancel, and I have x is equal to negative 4. At this point, it's pretty much the same as the previous example. We're now going to plug this x equals negative 4 into either equation, and it doesn't matter which one, but because I like to avoid negatives at all costs, if possible, I'm going to plug it into equation 1. So I'll make a little room over here for us to do that. And so if I've got 4x plus 3y equals 2, and I know that x equals negative 4, I'm going to have 4 times negative 4 plus 3y equals 2. I'm going to go through and simplify. So 4 times negative 4 is negative 16 plus 3y equals 2. And now I need to solve this equation for y. So I've got to get rid of this negative 16 first. And to do that, I'm going to add 16 to both sides. So negative 16 plus 16 plus 3y, and again, over here, I have to add the 16 since I did that on the left, so 2 plus 16. And so I see that my negative 16 and my plus 16 cancel out. I have 3y equals 18 over here for the 2 plus 16. All right, and now I'm going to divide on both sides by 3 to cancel out. And so I figure out y equals 18 divided by 3. And you know 18 divided by 3 to be 6. And so now I've got my x term, I've got my y term, and now I'm going to put those coordinates into ordered pair form. So my x is negative 4, and my y is 6. And so that's the solution to both of these equations. That's the point that is going to work for both of these and make both of these equations true with one point. It's the same as if we were graphing them or looking at them on the graphing calculators. They would intersect at the point negative 4, 6. All right, so sometimes you will need to rearrange things. As we see, we were used to having these things line up perfectly. In this case, they don't. These are in standard form right here, and this is close to slope-intercept form, but not quite. So real quick, I'm not going to go through and solve it, but we are going to rearrange it. So if I have 8x minus 4y, and I want the other one to look in standard form like this one, I'm going to need to rearrange. So if I have 4y equals 3x plus 14, I see that I really want my x to be on the same side as the y. So I'm going to manipulate equation 2 a little bit to move the x to this side. And so if I want to move that, because it's a positive number, I'm going to have to subtract 3x from each side. So 4y minus 3x equals 3x minus 3x plus 14. Okay. On the right-hand side, these are going to cancel. On the left-hand side, there's nothing that you can combine, but look back to the order here. The x term is first, the y term is second. So I'm going to rearrange it, and I have to remember to bring the negative sign. So the negative 3x is going to go out front. It's going to be plus 4y, because that 4y is positive, and over here all we have left is 14. So at this point, I now have equation 2 in the form of equation 1. We can line it up. We'll have 8x minus 4y equals negative 4. And below that, we can put our new equation 2. That's a negative 3x plus 4y equals 14. And now it's up to you to solve this system right here. As you can see, the 4y and the negative 4y might cancel out, so we would add these terms, and by combining these terms, we're going to end up with 5x equals 10, and I will let you solve from there. If you need help, make sure you ask. Again, you can pause the video to catch up if you need to. I'm going to give you guys these 6 practice problems. I'd like you to do as many as you can. Remember, you can pause the video to write them down, And if you get stuck, just ask for help. Good luck.